Hello everyone, how was your day? Welcome back to Artificial and Facts channel. And in this video we are back with a new topic, and the topic is indifference curve. And first we will learn what an indifference curve is. A popular alternative to the marginal utility analysis of demand is the indifference curve analysis. This is based on consumer preference and believes that we cannot quantitatively measure human satisfaction in monetary terms. This approach assigns an order to consumer preferences rather than measure. Let us take a look. So, what is an indifference curve? An indifference curve is a line showing all the combinations of two goods which give a consumer equal utility. Each point on an indifference curve indicates that a consumer is indifferent between the two, and all points give him the same utility. In other words, the consumer would be indifferent to these different combinations. Indifference curves are heuristic devices used in contemporary microeconomics to demonstrate consumer preference and the limitations of a budget. Economists have adopted the principles of indifference curves in the study of welfare economics. Graphically, the indifference curve is drawn as a downward sloping convex to the origin. The graph shows a combination of two goods that the consumer consumes. The above diagram shows the U-indifference curve showing bundles of goods A and B. To the consumer, bundle A and B are the same as both of them give him the equal satisfaction. In other words, point A gives as much utility as point B to the individual. The consumer will be satisfied at any point along the curve, assuming that other things are constant. And next we will move on to the properties of an indifference curve, or IC. And here are the properties of an indifference curve. First, an IC slopes downwards to the right. This slope signifies that when the quantity of one commodity in combination is increased, the amount of the other commodity reduces. This is essential for the level of satisfaction to remain the same on an indifference curve. Second, an IC is always convex to the origin. The diminishing marginal rate of substitution, the rate gives a convex shape to the indifference curve. However, there are two extreme scenarios. Two commodities are perfect substitutes for each other. In this case, the indifference curve is a straight line, where Mrs. is constant. Two goods are perfect complementary goods. An example of such goods would be gasoline and water in a car. In such cases, the IC will be L-shaped and convex to the origin. Third, indifference curves never intersect each other. While ICs will never intersect each other. Also, they need not be parallel to each other either. Look at the following diagram. This diagram shows two ICs intersecting each other at point A. Since points A and B lie on IC1, they give the same satisfaction level to an individual. Similarly, points A and C give the same satisfaction level, as they lie on IC2. Therefore, we can imply that B and C offer the same level of satisfaction, which is logically absurd. Hence, no two ICs can touch or intersect each other. And fourth, a higher IC indicates a higher level of satisfaction as compared to a lower IC. A higher IC means that a consumer prefers more goods than not. And last, an indifference curves never intersect each other. This is not possible because of our assumption that a consumer considers different combinations of two commodities and wants both of them. If the curve touches either of the axes, then it means that he is satisfied with only one commodity and does not want the other, which is contrary to our assumption. And you may wonder what defines the convexity of indifference curves. As you go down the curve of an indifference curve, the curve becomes flatter as one good is substituted for the other. It is the individual's marginal rate of substitution, which is defined as the more an individual consumes good A in proportion to good B, the less of good B the individual will substitute for another unit of good A. And next is the slope of the indifference curve. The slope of the indifference curve at any point is the negative marginal utility of good A as a proportion of the marginal utility of good B. It indicates that the optimal consumption bundle, the marginal rate of substitution between goods A and B, is the ratio of their prices. Now we'll move on to indifference curve analysis. Indifference curves are based on a number of assumptions, such as that each indifference curve is convex to the origin and that no two indifference curves ever overlap. When obtaining bundles of commodities on indifference curves that are farther from the origin, consumers are supposed to be more satisfied. The majority of the time, indifference curve analysis assumes that all other variables are stable or constant. The slope of the indifference curve is referred to by the misses. The misses measures how eager a consumer is to trade one product for another. If a customer values a banana, for example, the rate of substitution for watermelon will be slower, and the slope will reflect this rate of substitution. Now we will talk about the 4 characteristics of indifference curves. First, indifference curves can never cross. Second, the farther out an indifference curve lies, the higher the utility it indicates. Third, indifference curves always slope downwards. And fourth, indifference curves are convex. An indifference map is a set of indifference curves. It depicts the complete picture of a consumer's preferences. The following diagram shows an indifference map consisting of 3 curves. We know that a consumer is indifferent among the combinations lying on the same indifference curve. However, it is important to note that he prefers the combinations on the higher indifference curves to those on the lower ones. This is because a higher indifference curve implies a higher level of satisfaction. Therefore, all combinations on IC1 offer the same satisfaction, but all combinations on IC2 give greater satisfaction than those on IC1. And next we'll move on to the equation of a typical indifference curve. It is UT, Y equals C, where the constant stands for the utility level achieved on the curve. Different values correspond to different indifference curves. If we increase, we obtain a new indifference curve that is above and to the right of the old one. Here is an example to understand the indifference curve better. Peter has 1 unit of food and 12 units of clothing. Now, we ask Peter how many units of clothing is he willing to give up in exchange for an additional unit of food so that his level of satisfaction remains unchanged. Peter agrees to give up 6 units of clothing for an additional unit of food. Hence, we have 2 combinations of food and clothing giving equal satisfaction to Peter as follows: 1 unit of food and 12 units of clothing, 2 units of food and 6 units of clothing. By asking him similar questions, we get various combinations as shown in the video. And next we will talk about the shape of an indifference curve. The indifference curve has 4 points labeled on it: A, B, C, and D. Since an indifference curve represents a set of choices that have the same level of utility, Lily must receive an equal amount of utility, judged according to her personal preferences, from 2 books and 120 donuts. She would also receive the same utility from any of the unlabeled intermediate points along this indifference curve. Indifference curves have a roughly similar shape in 2 ways. 1, they are downward sloping from left to right. 2, they are convex with respect to the origin. In other words, they are steeper on the left and flatter on the right. The downward slope of the indifference curve means that Lily must trade off less of one good to get more of the other, while holding utility constant. For example, points A and B sit on the same indifference curve, which means that they provide Lily with the same level of utility. Thus, the marginal utility that Lily would gain from, say, increasing her consumption of books from 2 to 3 must be equal to the marginal utility that she would lose if her consumption of donuts was cut from 120 to 84, so that her overall utility remains unchanged between points A and B. Indeed, the slope along an indifference curve is referred to as the marginal rate of substitution, which is the rate at which a person is willing to trade one good for another so that utility will remain the same. Indifference curves like are steeper on the left and flatter on the right. The reason behind this shape involves diminishing marginal utility, the notion that as a person consumes more of a good, the marginal utility from each additional unit becomes lower. Compare two different choices between points that all provide Lily an equal amount of utility along the indifference curve. The choice between A and B, and between C and D. In both choices, Lily consumes one more book. But between A and B, her consumption of donuts falls by 36 from 120 to 84, and between C and D it falls by only 5 from 40 to 35. The reason for this difference is that points A and C are different starting points, and thus have different implications for marginal utility. At point A, Lily has few books and many donuts. Thus, her marginal utility from an extra book will be relatively high, while the marginal utility of additional donuts is relatively low. So on the margin, it will take a relatively large number of donuts to offset the utility from the marginal. At point C, however, Lily has many books and few donuts. From this starting point, her marginal utility gained from extra books will be relatively low, while the marginal utility lost from additional donuts would be relatively high. So on the margin, it will take a relatively smaller number of donuts to offset the change of one marginal book. In short, the slope of the indifference curve changes because the marginal rate of substitution, that is, the quantity of one good that would be traded for the other good to keep utility constant, also changes as a result of diminishing marginal utility of both goods. And next we will discuss about the field of indifference curves. Each indifference curve represents the choices that provide a single level of utility. Every level of utility will have its own indifference curve. Thus, Lily's preferences will include an infinite number of indifference curves lying nestled together on the diagram. Even though only 3 of the indifference curves, representing 3 levels of utility, appear on the video. In other words, an infinite number of indifference curves are not drawn on this diagram, but you should remember that they exist. Higher indifference curves represent a greater level of utility than lower ones. In Figure 1, indifference curve L can be thought of as a low level of utility, while is a medium level of utility and A is a high level of utility. All of the choices on indifference curve A are preferred to all of the choices on indifference curve which in turn are preferred to all of the choices on L. To understand why higher indifference curves are preferred to lower ones, compare point B on indifference curve to point F on indifference curve A. Point F has greater consumption of both books 5 to 3 and donuts 100 to 84, so point F is clearly preferable to point B. Given the definition of an indifference curve that all the points on the curve have the same level of utility, if point F on indifference curve A is preferred to point B on indifference curve More generally, for any point on a lower indifference curve, like L, you can identify a point on a higher indifference curve like or A that has a higher consumption of both goods, since one point on the higher indifference curve is preferred to one point on the lower curve. And since all the points on a given indifference curve have the same level of utility, it must be true that all points on higher indifference curves have greater utility than all points on lower indifference curves. These arguments about the shapes of indifference curves and about higher or lower levels of utility do not require any numerical estimates of utility, either by the individual or by anyone else. They are only based on the assumptions that when people have less of one good, they need more of another good to make up for it, if they are keeping the same level of utility, and that as people have more of a good, the marginal utility they receive from additional units of that good will diminish. Given these gentle assumptions, a field of indifference curves can be mapped out to describe the preferences of any individual. And that's all from this video. I hope you get something from this and see you in another video. Bye!